Welcome back to Separation and Mass Transfer Operations. This is an extremely important video, not just for this class, but for the rest of your career as an engineer, and it is about the importance of homework formatting and style. For those who have had me before, you know that one of my main philosophies is that when you're reporting your work, you should always not just write your equations, but rather explain them first. So your solution procedure is driven by your full sentence explanations to what you're doing, and then your equations are the supplement to what you're writing, and not the other way around. When you're finished, your submission should read like a solution from an example problem of a good textbook. Explain what you're doing first, and then show only the necessary steps in equation form. Next, I'll talk about why I emphasize this and also why you should care. You should recognize that when you get to your future job, you might work with separation processes, but you might not also. However, with 100% certainty, you are going to be presenting your work to your future supervisors and colleagues. When you present this work, you should recognize that your conclusion and your final answer is important, but more important still is the process by which you got to that answer. As I'm sure you've started to recognize by now, in engineering there oftentimes isn't one specific correct answer to any real-world problem, but rather answers that have benefits and drawbacks and caveats to them as well. And in those situations, it's absolutely critical that you describe what you did such that somebody could critically evaluate what you did in order to validate your conclusion. Next, I'll talk what specifically I'd like you to do. Once again, use complete sentences and prose to drive your logic, only writing equations when they've been properly introduced by text. So in this solution, I'm saying refer to the steam tables for saturated steam and water, and then that makes it clear that the values that I'm pulling come from that saturated steam and water table. I'm not just starting by writing something with no context. Note most importantly that algebraic steps are not as essential. I don't have to show all my scratch work or show all my calculations in order to show my work. What you can do is use my solutions that are posted to Canvas as examples, but you should be aware that mine aren't perfect either. And my goal for you is the same goal that I have for myself, which is not perfection, but to continuously and consistently improve. Once again, you don't have to write everything, but you should write enough such that somebody could follow your work start to finish. This is a very difficult and delicate balance to strike. It requires practice and feedback. You'll definitely be getting the practice that you need in this semester, and hopefully I'll be able to give you some feedback as well. But a lot of it is critical thinking and going back over your own work with a critical eye. So what's in it for you? Why should you care to do this? First of all, taking pride in your work feels very good and is easily noticed by attentive supervisors. I can assure you that I am somebody who notices these things, and doing this will increase my opinion of you as a student and as an engineer. Secondly, the future version of yourself is going to thank you come exam time because your work is going to be so much easier for yourself to follow. When I was an undergrad, I can't tell you the number of times that I went to study for an exam and I pulled out an old homework assignment, and even though I had just done it maybe 2 weeks ago, I had no idea what I myself was doing at that time. So writing your own logic like this is going to help you keep track of your own work so much better, and it'll make it easier for you to follow when you go to review. The last one sounds strange and maybe a little bit silly, but writing your logic really clarifies your thinking process. You may think that you're aware of what you're thinking, but until you actually write it down, you don't actually critically evaluate what you're thinking. So writing these steps is going to make you critically evaluate each step, and that will make the procedure easier to remember. On many assignments in this class, I'll ask you to make a plot using a computer program and then to report that plot. When you do that, the plot on the left is what I expect in terms of quality. However, the one on the bottom right is a typical submission that I get sometimes from students. While this is the Excel default, there's many problems with this plot, and there's many reasons why the plot on the left is so much better to look at and to understand. See if you can pause the video now and try to highlight as many things as possible that you can find that are different between the two plots. Hopefully you came up with a long list of improvements. Let's start with the scaling and the aspect ratio. If you notice, this is a plot of y versus x, and both of those are compositions that go from 0 to 1. So because the scaling is the exact same, I would expect that the graph should be a square aspect ratio instead of the default rectangular aspect ratio that you get from Excel. Also, notice how the Excel default goes past a mole fraction of 1, which is not a physically relevant value. So when you do a plot like this, you should always truncate your values to limit it to what is physically possible. You shouldn't even have 1.2 on the plot because a mole fraction of 1.2 is not possible. Next, it's absolutely critical that both of your axes have axes titles. So you should put what variable you're plotting versus the other variable. Preferably, you'd have units as well, although in this particular example, I'm plotting mole fraction versus mole fraction, which are both unitless, so I don't have to put units there. Also, chart title is something that you don't have to have, but if you do choose to have a chart title, please make it more informative than the default chart title that just says chart title. From an aesthetics perspective, dark bold font looks much better than the dull gray font that Excel uses by default. Notice how my axes are bolded with tick marks to show regularly spaced intervals. And also, I've put a border around the entire chart, but removed the border that it goes around the entire figure. The last thing I want to talk about is very subtle, but also very important for a reader to interpret your plot. On my plot on the left, on the blue line, notice that there's no data markers along that line, when in contrast, the Excel plot has blue markers that are along this line. And these markers are implying that I did some type of experiment to obtain the value. Now, there's no experimental component to this class, so a majority of the times we are not going to be using these data markers, unless the problem explicitly states that this is experimental data. So when you're doing a model, the rule is just do a smooth curved line, and when you're doing an experiment, you have markers, and your model is the smooth line that goes in between the data markers. Next, I'll talk about how to report work that you did in Microsoft Excel. You're going to be doing this oftentimes in this class. Many problems are going to be a lot easier if you use Excel, as I've said a couple of times before. And when you do this, it's important for you to recognize that a screenshot is the absolute worst way that you could report work done in Excel. For one thing, it's very difficult for a reader to interpret a spreadsheet if you didn't actually go in and lay it out yourself. For another thing, Excel does this weird thing where it has way too many significant figures. And also, I don't need to see the ribbon and the toolbar and all this other stuff that just add noise to the actual important thing, which is your solution procedure. On your homeworks, you can submit the actual Excel file if you'd like as a supplement, but I don't require it. And also, it's just not as useful as doing what I would suggest. And what I would suggest is when you report your Excel work, you just copy and paste the table or just the relevant parts, taking the appropriate care to format it. And then when you go back in your homework solution, you're putting what the formula is for each column. So here's an example. Some students prefer to type their submission, and that is absolutely fine. The only thing I require if you're going to type your solution is that you typeset your equations such that they look good mathematically. So this can be somewhat difficult to do, but Microsoft Word has a tool called the equation editor that if you just take a couple of minutes and familiarize yourself with what's possible, you can make your equations look a lot better formatted. I typically require my students to complete their homework solutions right on the pages of the assignment, such that everybody's answer is in the same place. However, in this semester, because I recognize that not everybody has access to a printer, and I don't want you to risk going out in public to the library to use a printer, I'm not going to require it. To scan your work, I personally don't have a scanner at home, but on my smartphone, there's many apps that you can use that will take a picture on your camera, and then it'll convert it to a PDF. So the one that I personally use is called Cam Scanner. That's the one I recommend to my students. It's a free app and reasonably easy to use. I'd like you to recognize that there's a difference between a photo, which is on the left, and a scan. So recognize that there's a difference between the contrast and the legibility in these two things. And Cam Scanner is really good, but sometimes it won't convert correctly, and you'll have to go back and do it again. When taking photos from your scans, you want to make sure to use a solid color background and take the picture as head-on as you possibly can, such that the lighting is even, there's no blurriness in the photo, and that the edges are automatically detected correctly. Compare the scan on the left, which is poorly done with edges that are not straight and blurriness, to the one in the middle, which is sideways, to the good scan on the right, which is what I would expect. I'd like to conclude this video simply by acknowledging that what I'm asking you to do may seem like a lot of work and it may seem a little bit annoying, but I assure you that I think it will make you a better engineer, and I wouldn't do it if I didn't believe this strongly. Additionally, I appreciate that you're willing to make the effort. Thank you for watching, and I'll see you in the next video.